Hello, I'm going to work on 10.7 complex numbers, which is a really fun topic. So let me go through it. When you're talking about complex numbers, these are all the things that we're going to do in this unit. There's a lot of parts in 10.7. We'll probably have like 3 videos. So let me go ahead and get started. When you have a negative number under the radical, what's going to happen is you're going to have something called an imaginary number. Now, the imaginary unit, I, is defined as follows. If you have the square root of -1, it is equal to I. When you have I squared, it is equal to -1. This is something that you're going to have to remember from now until we're finished with this entire chapter and this entire class. Because everything from now on end, we're going to have complex numbers, which have a real portion and an imaginary portion. So, the meaning of the square root of -b. What that happens is, the way I like to write it out, that it's not writing it out here, is the square root of -b is the same thing as -1 times the square root of b. So the square root of -1 times the square root of b. What happens is the square root of -1 is I. So that becomes an I. And then, of course, you can't square root b. So I just wanted to add that in there instead of it just jumps right to it. So let's do some examples. First of all, I know that the square root of -1 times the square root of 25. The square root of -1 is I, and the square root of 25 is 5. Well, mathematically speaking, we normally write it as 5i. So now this one here, we have a negative on the outside. And then we have the square root of -1 times the square root of 81. Now remember, the negative on the outside is just there. It's been there from the beginning. The square root of -1 is I. The square root of 81 is 9. That looks weird, so we're going to rearrange it a little bit. It's going to be -9i. Now this one here, we have the square root of -1 times the square root of 7. When you multiply them two together, remember, whatever's under the radicals are multiplied together. The square root of -1 is I, and you guys, you cannot square root 7, so it stays under the radical. Now this one here, we're going to have the square root of -1 times the square root of 4 times the square root of 11. If you notice, everything underneath that radical, when you multiply them together, you get -44. The square root of -1 is I. The square root of 4 is 2. And the square root of 11, you can't do anything with it. Now that looks weird again. I like to put the 2 first, then the I, and then the square root of 11. That's just one big giant multiplication problem. 2 times I times the square root of 11. Let's jump to the next page. Now, when you multiply radicals, whatever's under the radicals together are multiplied together, and whatever's outside the radicals are multiplied together. So, what I highly recommend that you do is this. The square root of -1 times the square root of 16 times the square root of -1 times the square root of 25. This is the best thing to do. The square root of -1 is I. The square root of 16 is 4. The square root of -1 is I. The square root of 25 is 5. Okay? Now, I times I is I squared. 4 times 5 is 20. So you end up with I squared is really -1. -1 times 20 is -20. There you go. That's that one. Now the next one, we have the square root of -1 times the square root of 6 times the square root of -1 times the square root of 5. So I broke it up for you. So we have I square roots of 6 times I square roots of 5. Whatever's outside the radicals are multiplied together. Whatever's under the radicals are multiplied together. So the square root of 6 times the square root of 5 is the square root of 30. Now the square root of I squared is -1. And you guys, we cannot square root 30. There's nothing you can do. Let's move on. Now, once again, the square root of -1 times the square root of 4 times the square root of 2. That gives you the square root of 8. The square root of -1 times the square root of 6 gives you the square root of -6. So I have I times 2, because the square root of 4 is 2, times the square root of 2. I can't touch the square root of 2. Then I'm left with I times the square root of 6. So remember, these are all just multiplication problems. I have I times I, which gives you I squared, times 2, times the square root of 2 times the square root of 6 is the square root of 2. So I'm trying to show, square root of 12. So I'm trying to show all my steps. I know that I squared is -1. -1 times 2 times the square root of 12. That gives me a -2 square roots of 12. You would think I'm finished, but I'm not. The square root of 12 can be broken down to the square root of 4 times the square root of 3. That is 2 square roots of 3. So -2 times 2 square roots of 3. Remember, what's outside the radicals are multiplied together, so that's going to give me -4 square roots of 3. So I tried to show all my steps. I'm showing everything. Now this one over here, this is just going to give me the square root of -1 times the square root of 5 times the square root of 7. So these are all just a big multiplication problem. This is going to be I, and I can't reduce the square root of 5, and I can't reduce the square root of 7. So what's going to happen is I'm going to get the square root of 35. So it's I square roots of 35. Okay, next one. I forgot to check the video. Time-wise, how many problems have I? Oh, I haven't done that many. I'll start my timer. Okay, sorry. I usually do a timer, so it lets me know like when to stop talking. And you're thinking, oh my gosh, stop talking, Miss Babcock. All right, you guys, I'm going to take care of the numerator. I'm going to take care of the denominator. So I'm going to get the square root of -1 times the square root of 16 times the square root of 5. I'm just going to write them all out. In the denominator, I'm going to have the square root of -1 times the square root of 5. Now, if you can reduce them, go right ahead. Now, the square root of -1 is I. Well, let me just reduce the numbers first. I know this will cancel out with this one. And I'm just going to be cautious, and I'm going to put I, and the square root of 16 is 4, over I. Now, I divided by I is 1, so my answer is going to be 4. Okay, this one over here, I'm going to have the square root of -1, and I'm just going to do this real quickly. The square root of 40 over the square root of 10. The square root of 40 and the square root of 10, because they're both under the same radical, I can reduce them. So I actually end up with I square roots of 40 over the square root of 10. 10 goes into 40 4 times. So I'm going to be left with I square roots of 4. The square root of 4 is 2. So my answer is 2I. Okay, I could have done this problem a whole bunch of different ways, but I'm going to just do it that way for now, just to give you guys some ideas. All right, a complex number has a real portion and an imaginary portion. All right, so here we go. I would like you guys to read through this when you have a moment. Please do so. We are going to start adding, actually I'm going to do the second video, so I will be back.